Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is
in the 1970s and 80s, I was a research computational mathematician who contributed new calculus and new algebra to the body of knowledge of modern mathematics. As an aside, on weekdays, I did my stability investigations full-time and alone. I conducted my mathematical research in the early 1980s and in College Park, Maryland, United States. Tennis was the diversion that took me off the mathematician's blackboard and took me away from the stress of inventing new calculus. On weekdays of the early 1980s, I spent the last 3 daylight hours at the tennis courts that were either in College Park, Maryland, or at the Rosemary Hills-Lyttonsville local park that was near my home of apartment 303 of 1915 East-West Highway, Silver Spring, Maryland. In the early 1980s, I spent my weekends in Baltimore, Maryland. The city of Baltimore describes itself as the birthplace of the U.S. national anthem, the Star-Spangled Banner. In Baltimore, I was a late afternoon regular at the Druid Hill Park tennis courts and at Clifton Park tennis courts. A recurring conversation with my older tennis partners was that during the 1950s segregation era, that Druid Hill Park tennis courts displayed whites-only signs. As a black African-born research mathematician, my presence within the American research mathematics community was very isolating. American science is grounded on a legacy of institutional racial discrimination. There is far more segregation and separation in American science than in American sports. That American legacy of institutional segregation and separation is the reason I was the only person to ever win the top prize in the field of supercomputing and to win that prize alone. In contrast, that prize is won only by a team of up to 50 supercomputer scientists that were armed with a supercomputer that cost up to $1.25 billion. My research in extreme-scaled computational algebra included my theoretical efforts to determine a priori the condition for the stability of the partial difference equations of algebra that I invented as approximations for the 9 partial differential equations of calculus that I also invented. That is, I investigated the error propagation and growth of my partial difference approximations, and I did so by simplifying the governing partial differential equations and by simplifying them to the heat equation or wave equation that is each linearized and that are described in standard references on the partial differential equations of calculus. For my finite difference discretization of the first order hyperbolic partial differential equation, my amplification factor was a complex number, and the stability condition for such first order hyperbolic partial differential equation is that the modulus of the amplification factor is equal to or less than 1. The eureka moment of my life occurred at 8:15 in the morning of the 4th of July, 1989 in Los Alamos, New Mexico, United States. That was the moment I discovered practical parallel processing and became the first person to understand it as the vital technology that will underpin every supercomputer. My discovery represented a major shift from the sequential processing supercomputer of the 1980s and earlier that computed with only one processor to the modern supercomputer that computes with up to 10 million processors. Practical parallel processing that I discovered for supercomputing changed the ways scientists, engineers, and researchers solved their toughest problems. The reason I remember that 4th of July 1989 so well was that it was the Independence Day of the United States. Because I realized that I was making history, I worked every day, including the Christmas days of the 1980s. Back in the 1980s, the supercomputer scientists in my small circle did not understand what I was working on and steadfastly declined my invitation to collaborate with me. It's normal for 50 multidisciplinary supercomputer scientists to have collaborated with me and do so to make my parallel processed supercomputer calculations completed a few years earlier. In contrast, I was able to solve the grand challenge problem of supercomputing and solve it alone. The reason I could solve it alone was that I had more scientific knowledge than each member of that 50-person team had. The knowledge that I acquired over 16 years of supercomputing was the reason a grand challenge problem that is impossible for 50 scientists to solve as a team of researchers is, in fact, possible for me to solve alone. Because I knew more about the parallel supercomputer than they did, I had a sense of urgency and the surreal feeling that I was making an invention that was bigger than myself.
Insightful and brilliant lecture.